This lesson deals with a three-phase AC power example. You can find these notes in the ECE202 ebook in Chapter 16 on page 32. Suppose that we have a delta connected load with a per phase impedance of 40 plus J30 ohms, and it's driven by a balanced positive sequence three-phase generator which has a line voltage of 2.4 kilovolts RMS. Using the phase voltage V sub AN as a reference, can you find the phase currents, find the line currents, and then find the average and reactive power delivered to the load? Using our formulas from page 29 to find the phase currents, I1, I2, and I3, it's equal to V sub AB over Z, so 2.4K at angle 30, divided by the impedance 40 plus J30. Putting this into polar form, we've got a magnitude of 50 and an angle in the first quadrant of 36.9 degrees. This ratio is 48, and the angle is the numerator minus the denominator angle, and that will be amps RMS. You can also calculate the current I2 in a similar fashion, but just simply shifted by 120 degrees. So let's take our last result and subtract 120 and subtract 120 again. To get the line currents, we'll need to do a transformation from a delta to a Y, and we can use our formulas from page 30. That's just simply taking our impedance and dividing it by 3. Also on page 27, we have the formulas for the line currents as V sub AN over Z sub Y, and that's going to be 2.4K divided by the square root of 3 at angle 0, and then our impedance divided by 3. You can bring this 3 up into the numerator as the square root of 3 times the square root of 3 and cancel one of those, and I've got 2.4K then multiplied by the square root of 3. And of course, we found this to have a magnitude of 50 and an angle of 36.9. So this ratio is 83.1 amps, and the angle is 0 minus 36.9. And again, that would be amps RMS. Likewise, we can find the other currents quickly by simply shifting by 120 degrees. So subtracting 120 and then subtracting 120 again. And lastly, from page 31, we had our formula for apparent power, and that's the square root of 3 times V sub L I sub L at angle theta. So that's the square root of 3 times 2.4K times 83.1 amps, and the angle is 36.9. So this product gives me 345K, angle is still 36.9. Again, that would be volt amperes. Putting that into rectangular form by multiplying by the cosine plus J times the sine of 36.9, I get 276K plus J 270K volt amperes. So our real power is 2.76 kilowatts and our imaginary power is 207 kilovars. This is an example of three-phase AC power.